Well, howdy, physics sleuths and inquisitive souls, and welcome to this episode of Dynamic Gravity. This is going to be just a brief introduction into how dynamic gravity works, the theory, what it says, and various points that go along with that. So, first, I think it's proper. I should probably talk about who I am, so you have some idea who this guy is talking about. This crazy new theory that goes against all of modern physics. My name is Sean. I'm really a nobody, but I do have a degree in physics and math from University of South Florida. So I don't think that makes me any foremost, world's leading expert in anything regarding those subjects. But I have spent many years and countless nights studying till 3 o'clock in the morning, physics on all levels and math. And I do believe that means that I at least have the ability to, use my brain power to figure out what's going on here. So I learned a long time ago in college. It was one of the first classes I had. One of the first things they told us was that we know general relativity from Einstein is wrong. It's just no one else has come up with a better theory for how gravity works and can prove it yet. So that's what we go with. So I dedicated my life to try and figure out gravity. And after about, I don't know, maybe 10 or 15 years of this, I finally got a breakthrough. And, thinking about this every single day, all day long, I finally thought about it from the proper perspective. And let me tell you what that perspective is. It's that gravity requires energy to operate or manifest itself, as does every other single known force in all of nature. This is a fact. But according to Einstein, there is no conservation of energy for general relativity. It doesn't exist. There's no energy loss occurring when you're spending energy or whatever to warp and bend space-time. It just doesn't exist. It's not in the equations. It doesn't exist. It doesn't observe conservation of energy. And that was the beginning of how dynamic gravity started for me, was thinking about, well, how would gravity operate if it did operate off of conservation of energy. And the best solution I could come up with, excuse me, apologies, I have brain damage getting blown up in Iraq, so I do cough a lot. Apologies. But let's think about this. Conservation of energy. I think that the best solution for this, to satisfy this for gravity, is to utilize one of the existing fundamental forces that we know and love and have studied to death, particularly the electromagnetic force. All right, so basically the electromagnetic force is the force that is between a proton and an electron. Yeah, it's a little E, a horrible E, but it's supposed to be an E. So they're emitting fields and interacting with each other, and they're drawn to each other. The electron is drawn to the proton. And this is the electromagnetic force, not electricity, not magnetism, not electromagnetism. This is the electromagnetic force. It is a fundamental force, one of the four fundamental forces that we know of, one of which being gravity, which we currently have no understanding of whatsoever at all, if you don't believe me or Einstein, which is very possible. So you have this force between the electron and the proton, and it uses energy in the form of heat to manifest itself. We know this because whenever we put an atom into absolute zero, all of these fields that are generated by the molecules, not molecules, but subatomic particles, disappear, and then the atom just kind of reverts into a what is it called? A state of where the atoms have no physical properties, like they merge into like a plasma. And then when you heat them back up again, they reform as they were originally. So they are retaining their knowledge of what they were somehow, even though you take away all the energy out of the system. You put the energy back in the system and it reverts back to the way it was. So it runs off heat. This is what powers this force and all the other forces, the fundamental four forces. So let us delete this. Now, how does this create gravity, you might be thinking? And that's a really good question. It's not an easy concept to understand intuitively. It definitely requires to think about it for a few minutes, but let's see if I can't, get you there right now. So, we got a bunch of atoms, right? Maybe not even a bunch, just let's say two. We got a proton here and the electron here. And the proton has its fields that it's emitting, the electromagnetic force field is what that would be. And let's say we got another proton here. And it also has an electron, a hydrogen molecule, we'll say, right? And, it's doing its thing. It's safely away from this guy. Well, what happens now is as this gets closer and closer to this other atom, you see how these fields start intersecting themselves? Well, they're going to interact. It's the photon is the carrier particle for the electromagnetic force. It's a photon. And although photons don't interact with each other, the fields do, because they're virtual photons and they act a little differently. But we know this because, if you have two charged particles, they interact with each other. They pull themselves closer, push them further away, depending on the charges. Or a magnetic field. Two magnetic fields will push each other, together, and the fields will interact and present force. So the closer you get these together, the more force. Where did this go? The more force that these guys are going to generate, and that's going to displace. And there's going to come a point in time when they stop behaving like two separate external fields and behave like one big field. All right, and now they are behaving as one big field. And what is happening is that electromagnetic force field is getting displaced out further than what it was normally. When you put these two atoms together, the field is not going to get larger by the width of an atom. It's going to interact and get displaced out much further than that. And the effect grows exponentially when you get enough of them crammed together tight enough. So, let's say we have a big molecule, or a lot of molecules together acting like one big molecule, creating a force. Like, say, the Earth. This is the Earth, and it is a bunch of molecules crammed together, packed density of like 5.0 or something, about the density of iron, I believe, not mistaken. There's the average density of the Earth. Maybe not quite that high, but it's close. And it is pitting out a large field that is going to pull to it all negative entities. We'll say this is a positive field, right? Because the protons are generating, let's say, the positive field, and the electrons are the negative field. So this is all the protons working together, being smushed together in atoms and a larger object like a a ball of lead or the Earth. Now, this is a positive field, and it's going to pull to it all the negative entities, which are electrons. That's what it is. So let's say you have another atom that might be kind of far away of hydrogen, once again, and this hydrogen has an electron, and it is got its own little field, as all protons do. Now, this particular electron right here, and this is the proton, it's going to be drawn to this proton in this field, all right? It's how the electromagnetic field works. So it's going to be binded to this. We're going to call it its parent proton, all right? Because that's the one it belongs to. It's what it's binded to. Now, if it's in the field of this Earth, it's also going to feel the pull to the Earth. And it's going to feel a much larger pull than this proton. Now, the field of the Earth is not going to be strong enough to rip the electron away from its parent proton. It only like a really, really incredible field will be able to do that, like a celestial, super celestial, like a black hole. That's why I like to call them super celestials, because they break all the rules. It's like a black hole, maybe a neutron star, and we are so undecided. But that's where you get so strong that it's going to rip atoms apart. It's going to rip electrons off of protons. But for the most part, any other celestial body, it's going to have enough of effect to pull on this electron, but not enough to rip it away from this proton. So what does that do then? That means now that this entire molecule is now pulled close, because this electron is being pulled towards the Earth one way or the other, but it's pulled, the electron is in tow pulling this proton. So it creates an external force on the entire atom itself, pulling it closer and closer to the Earth, all right? This is the force that we call gravity. This is what gravity is. This is how it operates. And this explains why subatomic particles that aren't electrons really don't seem to be affected by gravity so much, because they might not be electron like an electron is, and so they don't have the quark interaction of the electromagnetic force field, and they're not being affected by it, not like regular everyday matter is. And just so you know, all matter that you hold in your hand, all matter, it has electrons in it, all of it. Even neutrons, which are embedded into the core of the atom, are nothing more than a proton that is swallowed an electron, neutralizing its charge. Hence, now it's a neutron. So the only thing in the whole planet that doesn't have an electron embedded into it, one shape or another, is the unpaired proton. And this is also the most unstable particle in known physics, so unstable they can't even weigh it, which is very suspicious. That according to dynamic gravity, if you had a proton, it would also be creating its own little positive field, just like the Earth is. And then when you mix the two together, it's not going to be pulled towards the Earth, it's going to be repelled from the Earth. You would expect protons to shoot up towards space and make their way free into space. And we know this happens because there's a lot of protons in space, charged particles. But also other atoms, lighter atoms like hydrogen and helium, do also get to space too, because they're so light. But the proton, modern physics will tell you, will go to space too because it's lighter, but in reality this is the mechanism that's going on. It doesn't have any electrical negative entities embedded into it for gravity to operate on, so it is free of gravity, and it's actually anti-gravity in a way if you think about it, because it's going to have the exact opposite effect of gravity. So this is the generic basic of how dynamic gravity works, like on a molecular level, how gravity is being generated. This is something that Einstein's general relativity cannot explain to you. It just simply, Einstein's general relativity, as is today, just simply says that somehow through magic or unexplainable mechanisms, maybe using gravitons or maybe not, or space-time, the fabric of space-time, or something's going on. But you know, space-time is being bent, and you have geodesics that are, you know, determining how things move and flow and everything. There's no evidence for it, really. I mean, there's a lot of evidence for general relativity, don't get me wrong, but the beauty is all of that evidence goes towards my theory of dynamic gravity as well. In fact, much more. My theory explains the capacious sorting effect of the planets. How the closer you get to the source of gravity, like the sun, the smaller the planets are. My theory explains this. I'll do another video to explain this later on. I don't want this one to be too long. But so basically, my theory explains that. According to general relativity, it's just a coincidence. My theory explains and predicts dark matter. It also explains and predicts dark energy too. The Einstein general relativity cannot explain this. It's impossible. You know, this is why to this day they don't know. They have no clue what could be causing this, because it's not supposed to happen. The only why they know something's going on is because whenever you use Einstein's math outside of the solar system, you have like a 90% error rate. It goes pretty wrong pretty fast. So that's the creation of dark energy and dark matter. But my theory explains this, and I'll do a video how this mechanism operates, you know, soon. I'm working on it. It's just got real life going on. My theory also explains time dilation. It explains what time dilation actually is, where Einstein hasn't a clue. They can't. There's no one that believes in general relativity on the planet that can tell you how time dilation really works or behaves. They just simply have curves and diagrams and like, oh, we do this and move it together, and then they are paired in frame of reference and blah, blah. There's no mechanism, though, what's going on. It doesn't exist. My theory also would predict galactic black holes, something that is not expected, and something like a general relativity, because it's such a huge, massive object, you wouldn't think to have it. Breaks all the rules. And also there is this this one thing right here. I want to show you this. This is a really big one too for me. This is the one that really caught me on to what was going on. This is the four fundamental forces interactions, and you can see here there's a strong force. It has a range of 10 to the minus 15th. Its fall off rate is like, I don't know, R cubed or something. The weak force is 10 to the minus 18th. Its fall off rate is like R to the 4th or something. I have to look it up exactly, but it's. And then electromagnetic force has an infinite range, because even though it diminishes, it's R squared fall off. It's always going. It never stops going. It's R squared. Well, guess what? Gravity, this force that we have no clue what it is, also has the exact same range and fall off rate as a photon. According to my theory, this is what you would expect, because the virtual photon, the particle that facilitates the electromagnetic force field, is also the same one that facilitates the gravitational field in my theory. According to modern physics and general relativity believers, this is a complete coincidence that you should not look into and don't worry about. You know, let the scientists sort this out. So yeah, I don't believe that's a coincidence. That tells me that the same carrier particle, the virtual photon, that's working on the electromagnetic force field is also doing the same for a gravitational field. And my theory explains how that's happening on a subatomic level. So the only evidence that goes against my theory, I feel like I have to at least let you know that the one thing my theory does not say that we've seen and observed is light bending from a gravitational field. There's really no mechanism inherent in my theory that can explain that, but I do think it's fair to say that the same particle, the virtual photon, that's an electromagnetic force, between the proton and electron that is involved in creating a photon, is the same for my gravitational field. So in effect, the same field that generated and created a photon is the same one that a photon is attracted to somehow in some way. I haven't figured that out yet. I'm still working on it, but it's not outside the realm of a possibility. It's just something that is unpredicted that I can't explain at this point in time. But I think I really do feel like I've figured out gravity. It makes perfect sense to me. All the observations, I know what's going on. I can explain this. General relativity really can't. But general relativity can also has the math, which I don't have right now. So that's a huge thing for general relativity. Even though Einstein said gravity must work as a field, or it's impossible to do what it does. He says that in the very first page of his special relativity thing in like 1908, going on photons. I'll show you another video on that one day. But I think we've gone over enough today. I hope that you understand at least generically how dynamic gravity works, and at least believe, whether you believe it's real or not, or possible or not, just to at least believe that it's plausible, that, okay, I see what he's going at and I can't really disprove it. I'm not saying I believe it, but yeah, it's possible. It's possible, maybe. We'll see. That's all I'm really hoping for these days, talking to most people. But even that is asking a lot. So thank you for your time. Have a good day. Adios.
Like, subscribe, submit.